Good morning. Welcome back to the atomic structure. Now, yesterday we have seen Rutherford model of the atom and all the problems also. Then we have seen the James Maxwell electromagnetic theory, which would able to explain very clearly the diffraction, interference of the properties of the light and all these things. But the same electromagnetic wave theory could not explain some four observations. One is black body, photoelectric effect, and variation of heat capacities of the solids with respect to the temperature, means as a function of temperature. Then line spectra of atoms, especially the hydrogen. So now one by one we will see what is the actual these parameters. With the heat capacities of the solids with respect to the as a function of temperature is take a iron solid, heat it in a blast furnace. Initially it is emitting a dull red. As you are increasing the temperature, the dullness is coming down and the brightness is going on, so it is becoming the pure red and all. Further, if you are increasing, it will become pure white. Further, if you are increasing the temperature, it emits the blue light. That means as the temperature increasing, it is emitting a higher frequency radiation, low wavelength radiation, and goes on. This could able to be explained by Planck through his the particle nature of the electromagnetic radiation or quantum theory. So then next one is comes to the what is black body. A black body is nothing but which emits all the radiations and which absorbs all the radiations. A body which absorbs all the radiations and which absorbs emits all the radiations is a black body. Whatever the black body is emitting the radiations is only the black body radiations. And it is Planck has given the quantum he called h nu is the one frequency, that means each one will have its own particular pocket of energy, right? Intensity versus the wavelength and the graphs and all. Then what is photoelectric effect? Photoelectric effect, interestingly, they carried out the experiments on some of the metals, potassium, lithium, cesium, rubidium, like those metals they take. And they one glass tube they took, and they normally as usual you have to vacuum the chamber, means no pressure should be available, and irradiate the metal with this radiation. Interestingly, below certain frequencies, depends upon the metal, nature of the metal, electrons are not coming out instantly. In some cases, that means if the energy is sufficient, electrons are ejected immediately. So after carrying out so many experiments, they found out that there is a frequency requirement for electron ejecting from a metal, that is called threshold frequency. Einstein has proposed that is called a work function also, and that depends upon the metal and the frequency also, means it depends upon the metal of this thing, and energy also depends upon the amount of, means ejected electron energy, kinetic energy is dependent upon the whatever the energy you are given, photon energy. So he could able to explain that whatever you are giving energy is a conservative. So h nu if you are giving, h nu equal to the threshold energy or work energy, parameter h nu 0 plus half me square. So that is the principle totally he has explained the Einstein with the Planck's the photon theory and all. The last one is your line spectrum. If you see, when you are irradiating when you are bombarding with the radiation on a sample of the metal or whatever the sample, it is a characteristic of that particular sample. If it is only uniform, it absorbs the sum of the frequencies remaining. Suppose if I am passing the entire spectrum of the radiation on the sample, the few frequencies are only absorbed by that particular sample. Those lines are missing in the spectrum. The same way, if it is going on irradiating and whatever it is emitting, if you are observing, few lines are available. So the meaning is, emission spectra or absorption spectra is a characteristic of that particular this thing. Either it is absorbing or it is emitting, that means excited atom. After radiation, it is got excited. Electrons are excited, so atom is excited or ion is excited. So that excited state, from that state, it will not stay there, it will come back. While coming back, it will emit. That is emission spectra. That means one is if you are taking a phototype, one is a negative, another is a print. So one atomic absorption or the ionic absorption or the molecules absorption or atomic emission, different. Spectroscopy is a very big subject and it will be dealt in the higher classes and all. So those things will be dealt by the higher classes. So then comes to this Bohr. Bohr has proposed many things, but initially we will see what is the. Now Bohr has proposed there are the fixed orbitals like what Rutherford has told. As long as the electron is moving in that orbital, it is not going to emit or absorb anything. Once it is absorbed, if it is excited, it will go to the next higher levels and all these things. Then it is absorbed. Then only again if it is coming back, it will be emitted. So the energy transitions will be from when the orbital to orbital. As long as it is within the orbital, there is no instability to the electron or atom. That's what proposed. So there are so many drawbacks that we will see later. Then now scientists have a doubt whether the James Maxwell's electromagnetic wave nature is true for radiation, or the Planck's quantum theory, that the photon theory, particle theory is correct. Which is correct? Then to explain overall these things, Broglie and other these things, they have explained that radiation will have the dual nature. It is sometimes it behaves like a wave, sometimes it is like a particle. Photon, not proton, it is a photon and it is a particle. So sometimes it behaves like a wave. When you want to explain this thing, and it means while in the propagation, it will move in as a wave. While interacting with the matter or particles or these things, it will behave like a particle nature. So the electromagnetic radiation will have the both qualities, wave nature as well as the particle nature. So that is the finally everybody is accepted and concluded. So that was the final theory. Afterwards again it will come for the quantum, the Schrodinger equations and all. Before that, so to explain more clearly about the atoms, because we are in the atomic structure, that will go to the physics longer and higher states. We have the quantum, because Planck has proposed the atom is the quantum line spectrum of hydrogen. To explain the line spectrum of hydrogen, he has proposed some starting with the quantum numbers. What are those 4 quantum numbers? Today we will see just the names. That is the azimuthal quantum, principal quantum number, azimuthal quantum number, and magnetic quantum number. The last one is the spin quantum number. So tomorrow we will see each one in detail. What is this importance and how, that is the basics actually for the chemistry. the how electrons are filled, because this was also not could not be explained by Rutherford in his atomic model. The Bohr's atomic model and this Planck's and Balmer series, Rydberg series, all these things will come. So how the electrons are distributed in an atom will be by the next onwards. That means by this principal quantum number, azimuthal quantum number, and the magnetic quantum number, and spin quantum number, and uncertainty principles, and all these things. So actual chemistry, atomic chemistry or atomic structure, this thing, actual structure starts with this. This will all whatever it is only basics. That basics will be the physics or chemistry, whatever it is. Okay, thank you.